Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In our last video tutorial, we estimated a height value in meters for each of our built-up structures. So that's what we spend most of our time on our last video. Okay, so we estimate for each of our 50,000 built-up structures that we've identified using an open building platform. We've then, as I said, they generated a height value. So that now ultimately gives us for each built-up structure within our region of interest. Okay, so for each built-up structure, let's just unselect it. So for each of these built-up structures, we now have an area size, height and width, and we have a confidence level. How confident are we that it actually is in built-up structure? And then we've now also calculated the height. So if we multiply the two with one another, the area and the height, we can get the volume or the total size of the building. In other words, stuff that we can do. Okay, so that's ultimately what we are aiming for. Okay, so remember, to do this, the first thing that we had to do was to generate our canopy height models. Okay, let's just go to them. Okay, there they are, our two canopy height models, which is basically our digital surface images subtracted by our digital terrain images. Okay, so there are the three images that we're working with. We're working with our digital terrain image, which is this particular data set. Let's quickly go there and have a look at it. Copy and paste it in our data set on our catalog, Google Earth Engine catalog. And just to familiarize yourself with us, it's 2010 version. Don't have too much of a problem with that, since there's very little that the surface of the Earth would have changed that dramatically from height above sea level, okay, elevation. Okay, so that's the digital terrain model. Okay, and then we've got two digital surface models. This one here, I think this is the older one of the two. It's, I think, 2010 or 2011 or thereabout. Let's quickly have a look at it. Yeah, 2011. So if we've got a medium image, most probably 2009, 8, 9, thereabout. And that makes it not ideal because it predates a lot of built-up structures. So you would have, according to your image, there was a build-up structure. So it will say there's a build-up structure, but according to that specific image, that digital surface model, there's nothing. So your height would most probably be very little, which is puzzling, but just be aware that these buildings most probably outdated or post-date this particular digital surface image. There's our second digital surface image. Although it says it's a DEM, a digital elevation model, it's actually also a digital surface model. And that one is a little bit newer. It's a little bit more relevant. Okay, so medium one will be about, what's it, 2012, 2013, thereabout. This is 7 years later, but still quite old. Now, if you have a newer version for your region of interest, use it. Okay, so if we display those three images, okay, so let's make it so that we're going to display those three images. There's the first one, the terrain model. Remember, dark blue is basically same as very small above sea level. Height is very small above sea level, most probably sea level itself, and red is very high above sea level. So remember, these are mountains. Okay, so this is high above sea level, very low above sea. You can see the river structures, which obviously is not very high above sea level. Okay, so that's the digital terrain, digital surface model, and you'll see the three of them are virtually, and that's because I've given them the same color schemes. You'll see there there's very little difference between the three of them visually. Obviously, it's in the detail, it's in the square meter, in the height value itself where there's a difference, but they should in theory not be that different. And then I said we've generated the two canopy height models, which is a subtraction, and these are the canopy height models. You see again there's very little difference between the two. There's the first model and there's the second model. Let's just wait for the second one to load. Okay, so there's the first model and the second model. Again, indicative of same color scheme, in that dark blue is very little difference, or very tiny height or small height, and then dark red is quite high. Okay, so that would be high or tall built-up structures, and this would be very small built-up structures or features. Not necessarily build-up structures, but features. Most probably trees and things like that on the mountain, or whatever. We'll have to have a look at it. Okay, so that gives us our canopy height models. Okay, there is the canopy height models, and we visually display them, etc. etc. So now, obviously, what we want to do, if we go back into our satellite image, and let's say we the build up, there we go. So there's our buildings. Okay, remember we brought them in as points, not as polygons. Okay, so each of these dots represents a built-up structure. Where are they now? Each of these points is a built-up structure. Okay, so there they are. You can see there. Remember, it represents the whole polygon, not just that area. Okay, and we have an, okay, there we go. And we have a canopy height model. So what we want to do is to allocate, or to identify the value of that canopy height model there in that specific polygon, and then allocate it to that house or that build-up structure. And we use, and this is the code that we use for it, a reducer. Okay, so that's the specific script that we use to do that that function. So okay, so we say, okay, let's use the remember we call it reducer. You can call it whatever you want to. It's going to reduce the image. What is the image? The image is this canopy height model, the one that we have here at the background. We're going to use the mean. Remember, there could be, so for example, this building there. Okay, so let's have a look at that one there. Remember this building there, some of its, remember the whole feature is this one here. Okay, that's just a center. So part of this building is located within one pixel of the canopy height model, and the other one is located in another pixel. So we're using the mean to calculate the height of this particular built-up structure. Okay, because it might have, it may lie within two different canopy height values. So we're going to use the mean of it, and it's evident if you again highlight. You see this one here most probably lies within this. There's a portion of the building that is in this value and a portion that's in this value, so we use the median mean to get the value. Okay, median mean would be exactly the same, because I doubt it will be more than two values that we have to allocate. Okay, so that's what we basically do. This one is evident, so there's no overlap. This one as well, there's no overlap. This one as well. This one may be overlapping with this. Oh, there might be three. If these different pixels are different in terms of its height values, it might be. Anyway, I think you get the idea. And we're going to use the build up, meaning these built up features. Okay, so remember that built up refers to this feature collection, the one that we brought in. Okay, so let's see what the size of this. Okay, so we wanted to calculate what is the size of this. Yeah, the size of it is 46. So there's 46 of these built-up structures. So we need to generate 46,742 height values derived from our canopy height model. Okay, and that's basically what we're doing here. Okay, we're allocating a height value derived from our Canopy model for each of these built-up features. Okay, and if there's an overlap, we use the mean reducer. Okay, so we reduce the region, etc. Then we're going to print it just for intersect. We want to print. Now, there's 46,000. There's no way it's going to give you 46,000. It's going to display all 46,000 features in that feature collections or build-up structures. No way, it's just too big. So we limit it to 10, and that's basically how you do it. Just dot limit. Remember, reduce this variable here. We limit it to 10 features, and that's it. So if you look at each feature, get the features there. So let's use number 5, for example. You see it's got 6 properties, meaning 6 columns. Okay, so remember it's a table. Each table will have columns, which is the lat and the long and the area and the confidence and all these things. And now we've created a new one there, which is mean. You see there's the value 2. So whatever this built-up structure is, we can determine that by looking at its polygon or its geometry. Okay, there's its coordinates 18, 66, 32, 61. So we can identify that location, and then we know that that built-up structure has a height of 2 meters. It has a confidence level of 68%, and it's got an area of 37. Okay, so remember these are the features, the columns, or the properties of that feature. Okay, and we've created now a new property which is called mean, which is the height, and that height is 2, and that's derived from the Canopy Height Model for that. Okay, now as I said, we can then display those heights by this variable here that we just created, this reduced variable, and we convert it back into a feature collection using our normal feature collection functions, EE feature collection reduced, and we can just clip it for just to make sure. We clip it again just for our region of interest, and then I display it. Remember that mean there must be that value there. Okay, remember the mean. If it's median, then it will be median. If you use sum, it will be sum. That will be sum. You must use sum here. Sum. Okay, so what the statistical reducer is going to be the name of your column, and that is what you're going to use to filter your feature collection. Okay, and then we're going to export it. So let's have a look and see if this thing works. Okay, so let's have a look at our height model or height values for each of these built-up structures. There they are. Remember, red is small buildings, not very tall. Yellow is medium-sized buildings or height buildings, and then green is high buildings based on our classification here. Remember, our small buildings minus 10 to 2.5 meters. Our medium buildings is 2.5 to 5, and our high buildings is above 5 meters. And you can see there they are. Now it makes sense that most of them will be smaller medium buildings. Especially this area, there's not there's no tall apartments and things like that. Okay, so that makes a lot of sense. It looks like it's accurate. I'm still concerned about the minus values, but nonetheless, let's have a look. Okay, so let's identify a specific area. Okay, let's have a look here. Okay, so this is looks like an apartment. This is a holiday flat, like 3 stories. And let's see what we can. So we're going to go to inspector. We're going to click on this one. Okay, we're going to click on this one here, because that would be a structure. Okay, so let's have a look and see what the statistics tell us. So the DM there is 4 meters. So the digital terrain model says it's 4 meters above sea level. The digital surface model says that building is 9 meters. So therefore, if we subtract the 2, the height of this building would be 5 meters. And that seems fairly reasonable. So the height would be 5 meters. Okay, so that building should now have a column or a property called, what did we call it, mean again. That would have a mean property of 5. So that building will now have a size, a confidence, and a height. And the height column would be called mean, and the value should be 5. Okay, so let's go and have a look at it. Let's see. So we're going to go into no buildings. So there's, okay, so there is, no, it doesn't indicate a building at all. So maybe it's outside of that building feature. Okay, so let's have a look and see. Okay, so let's click there, see if that one works. Okay, so we can always put it built up, activate it to see if we can, if there's actually a building there. Okay, so let's have a look and see. No matches. Okay, so also no good. Let's try this one here. See, that's loose standing. Or maybe just clicking outside of the building polygon. Okay, so let's have a look at that one. Let's make sure no matches. Okay, so let's click there. Let's click there. There should be something. Why is it giving me now? Why is it telling me there's nothing there? So let's, did I do something wrong? Nope. No buildings. What are we doing wrong? It's displaying them correctly. Everything seems fine. That seems fine. But just, yeah, see, it doesn't. Okay, so that seems fine. You see, that's one building, but we have, it's built up. So why is build up not? See, add map, add layers, build up is this one here. Why is it not displaying? Okay, so there you go. Okay, there we go. So let's have a look at that one again. Let's see what happens. What's going on now? What's going on now? Now what's going on? Why is it struggling? There we go. There we go. I don't know. Why is it? Okay, there we go. It's found something. Not sure what happened now. Anyway, so let's go back again. Okay, so at that building, it's 4 meters. Okay, so remember there's this one here. It's 4 meters. The digital terrain model, the digital surface model says 5. So therefore, the height of this building must be 5 meters. There it sits. Okay, so let's go and have a look and see if it's indeed the case. There's the height. Let's open that. And there's the properties. Let's go and look at the prop. There we go. Mean 5. Voila. So it is accurate, correctly allocated that mean value of 5 to that specific building. You see that value building is a height of 5 meters. You've got a confidence level of 83%, and it's got a square meters of 95 square meters. So that's quite a large, high building. So let's look at something else. Let's go and have a look and see another building, maybe which, you see, some of these buildings are in this particular area are fairly new. So let's go to the old part of town. This part here, let's go. This building has been here in existence for many, many years. Let's have a look and see if we pick up this building. Okay, so let's go and have a look at this one. So inspector, this is a single story building, so it's most probably not going to be very high. Let's have a look and just make sure there is a, yeah, okay, so there's a building there. Let's click on that one there. Okay, so let's have a look. Let's make it bigger here. Okay, so remember that's that area there. Okay, so it's got a DSM of 0. So basically it indicates there's nothing there. You see, there's a terrain model and DSM model. But anyway, let's have a look and see. It's got a 0 height. Okay, so let's go to the properties of it. This is this one here. Let's click there, properties. And this one says property 1. So there's maybe an overlap, 1 meter high. So that could be 2 buildings, different areas. Let's have a look and see. Yeah, you can see there. It's an overlap there. And that's why there's a different value. Okay, so that's quite cool. Let's click on that value there to see what happens there. See what the allocated height value is there. Okay, so there's a height of 1. So the terrain is 10, surface is 11, and it's got a height of 1. Let's have a look and see if we go to the feature collection of building heights. Let's click on that one there, and properties. Yeah, mean is 1. Okay, so the numbers are questionable, but the functions work. The way of identifying the values and allocating it to this build-up features, that seems to work. It's just the numbers seems a little bit dodgy and not always, but the method and the methodology seems to work perfect. Okay, so now we have another feature collection. That feature collection is based on this particular feature collection, but it has added another column, and the column is mean, called mean, and its height. Okay, so it's got now not just the area meters of conformance, you also have this mean value now. Okay, so now we want to export it, and we use this particular function to export it. Okay, so we export it, and we export it to our we export it to our project. There's our export function, and we export it to our project as a CSV. Okay, in our Google folder. So we go to our Google folder. The file will be there within our project. Let's quickly go there just to show you. There's my Google folder. If I open my Google folder, there's the project. If I open that, it sits there. There's my CSV file. Okay, then I simply just go and download the CSV file, and if I open the CSV file, there's my open CSV file. It will open the CSV, but I've already converted it into Excel. And you see there's my mean value. Okay, the new column. So I've got area, confidence, geometry, and mean. Now, if I sort this, you'll see again, this is where dodgy. Don't know how this makes sense, but this indicates that that built-up structure has a height of minus 174 meters. Okay, so that means that it's 174 meters below sea level. Now that makes no sense, and we have to go and have a look and see what goes on. Could be the image problems, could be, I don't know. We can have a look at that. Let's have a look at the largest. According to this one, the tallest building in this area is 180 meters. Again, that makes no sense. There's no such buildings. Again, you see the area is small. You see these small little buildings, which most probably, you see again, this is small ones. We'll see small buildings. Okay, there's a big building that's got, but most of it is small buildings. That's where your problem lies. So if we go to the largest buildings, you see the largest buildings, their heights looks more accurate. Okay, there's some minuses that we have to look at, but you can see most of them are fairly accurate in the sense of its height. Makes more sense. So you have the outliers. So that's why I said, in general, what I do is I disregard all these. If we go to the small ones, you can see the small ones are ones with, okay, it's not too bad either. Yeah, so we do have our outliers, so it's up to you to decide what you want to do with those outliers. I would say that 90% of the buildings have height levels that's fairly consistent or fairly plausible. But there's about 10%, I would estimate, of buildings or built-up structures where the heights are a bit haywire. Now that could again be because at the time there wasn't a structure, and therefore the height value will not correspond to a structure but to empty space. So bear that in mind. Nonetheless, the methodology and the code, the script actually works, which is what we're interested in. The accuracy is something that we need to play around with, whether we need to work with the mean or the median. Whether we should, remember I worked only now with this DSM model, which is the older one, whether we should work with this DSM model. Here I use the sum statistics, and again, a reason why I don't want to work with the mean of a mean, so I work with the sum and then the mean. That makes to me a bit more sense. But so there's a lot of parameters that you need to play with to see what gives you the best results. But nonetheless, the script seems to work, the code seems to work. It does what we want to do, and that is to generate a height value for each built-up structure and create a table that we can use in a 3D format. So that's what we set out to do, and that's what we actually have done. The accuracy, the reliability obviously is questionable, and we need to spend a bit of time on that. But nonetheless, the code, the script works. Oh, I need to save. Remember, run and save, run and save. Okay. So that basically is our canopy height model for our region of interest, which, yeah, so gives you quite a nice dimension too. What else is a fairly static database. So we, are now able to generate derived statistics from our standard data sets. Okay. So I hope you enjoyed that. That was quite interesting. I thoroughly enjoyed it. So definitely something that I can use in my work, and something that one can keep on working with and exploring. Remember, this is not the end of the road. This is just the beginning of the road, and it's up to you to play with the numbers, the parameters, and see what fits best you, what works best for you. But yeah, thanks for joining me. Thanks for thanks for being on board this flight, this remote sensing journey. Please remember to like and subscribe, and stay tuned. There's lots more coming, and I'll see you on the other side.